So last time we tried making a video, Moby accidentally poured acid all over himself. He's in the shop right now, so I'll have to do the video alone. Dear Tim, what is the difference between an acid and a base? From Brad H. Well, Brad, there are several ways to determine whether a substance is an acid or a base. One of the most popular ways is using litmus paper. When you dip blue litmus paper into an acid, it becomes red. And when you dip red litmus paper into a base, it turns blue. For example, this piece of blue litmus paper, when tested in lemon juice, turns red. We now know for sure that lemons are acidic. When we test red litmus paper under soap, it turns blue, because soap is a base. Acids and bases also have specific properties you can identify them by. Acids, like this lemon juice, are sour, and bases, like this soap, are bitter. Soap is also slippery, which is another property of a base. Although these are safe to eat and touch, most acids and bases you wouldn't want to taste or touch, because they could be dangerous to your body.
Acid right here. I'll just fill this up with the acid, and we know that's 1 molar, meaning that's how strong it is. And then I made 1 molar base over here. This is called sodium hydroxide. That one's hydrochloric acid. So this sodium hydroxide is a base. And what I'm going to do is pour the base down here. About the same amount as the acid, about. Okay. And then in the middle, and you guys can watch this and actually film it, I'm going to fill this with water. And I want you guys to notice something here. So this is the water. You guys remember which, on the right, well, my right, acid right here, and base right here, correct? So this is my acid, this is my base, and this is an acid-base indicator. So do you remember what color acids were at the beginning of the year?
Red.
They were red. Good job. So you'll notice right away that that produces a red. And then what about bases?
Blue.
Kind of bluish. I think this one kind of comes out like purplish.
Indigo.
Yep, indigo, something like that. So, and then water, it turns out, is generally like a green. When I mix an acid and a base, what do I make?
Yellow.
Water.
I make water. Have you guys heard that acids and bases are, they neutralize each other. Have you heard that? Yeah. The reason is that when they react, they actually make water. Now, if this is sodium hydroxide and this is hydrochloric acid, guess what else I make besides water? Sodium and chlorine.
Salt.
You make salt. So what happens here is we're going to make water, and the color change should show that, but we're also, and you won't see it, but we'll also have salt in there. All right, so we'll make salt water. That's why a dangerous acid like this and a dangerous base can mix, and you'll see that they'll become the color of water here. So my chemistry class is learning a thing called limiting reagent. And that means one of these is going to limit the amount of reaction that I'm allowed to have. So if I put all the base, or a lot of base in there, and then I put a little acid, did I make any water there?
No. Yes, you
I did make some. They reacted. Which one limited how much I can make?
The acid. That's acid.
This is the acid. Which one of these colors limited the amount of reaction allowed?
The acid.
Base.
I have too much base, don't I? So this one limits the amount that I made. So what do I have too much of right now in here? Right, the color is showing me that I have an excess amount of base, and therefore I have a limited amount of acid. What happens if I add more?
Then it'll change colors.
Eventually, I should be able to get it to change color. Keep filming this. See that red starting to stick? Okay, watch this. Don't miss it. See how the red's kind of sticking around in there? I'm going to add a little bit more of this just to get more dramatic effect. Okay, let's do this again. See that pink starting to stick around a little longer? Starting to swirl in there. Not quite yet. We're getting really close though. Watch this. What did I just make?
Green, yellow.
We were there for a second, right? So we went a little past. Watch this. Just 2 drops. Two more. Let me shoot it all the way in there. Oh my gosh. Yeah, I want to make sure we get to the point where it's acidic. So check this out. Right now, which one do I have an excessive amount in there?
Acid.
An excess amount of acid. And then you'll see these purple,
Dots.
like swirlies in there. And if I do this right, should be able to get it. This is where I want it. So we still have too much acid, right? And we're really close to breaking just 1 or 2 drops, and it'll all of a sudden switch colors again, right? So what you're looking at, we're trying to get the exact perfect amount of acid and base. Today, you guys are going to do a thing, like this one might do it. It's starting to change to that yellow. You guys see it? And we're really getting close. I want to get it back to the water state. So I still have too much acid, and we're getting so close that just a little bit here. Get it? Right? This is what I want you guys to see. So, yeah, so watch this. 1 drop. Almost there. We're trying to get, we don't have water yet, do we? But we're getting really close. 1 drop. Oh, we're super close. Almost. Right? And there, we're almost getting to the point where we got water. You guys are hilarious. Reminds me of like a fish that changes color.
Do fishes change color?
What actually happens here, I believe, is that when you mix the air with it, carbon dioxide mixes with water and actually makes acid. So even when I get it to a point where it's really close to being water, we're really close right there. It's starting to kind of get that green tone. That's kind of where we want it to get that slight darker shade of green. They're pretty close to the same right now, right? I think I shot too much. That's about right. So I would say right now, yeah, I know, it refuses to do it. But you guys kind of catch on to the idea that we're mostly water in there right now. And there's some salt. And of course, if I squirt too much, I make the whole thing basic again, right? And then I can do this back and forth all day long. But what we want to learn from this is that if you get the exact right amounts of each ingredient, you can basically have even amounts of them, right? Like the correct balanced amount. Do you remember when and you can turn